the ailerons. In this module, we will look at the flight control system of the ATR. We'll first start out with a system description. Next, we will take an in-depth look at the roll, pitch, and yaw system of the aircraft. Following these systems, we'll examine the flap and gust lock systems of the aircraft. Finally, we'll review the controls and indicators associated with the flight control system. The ATR flight controls consist of one aileron on each wing, one spoiler on each wing upper surface, two elevators, and a rudder equipped with a spring tab. These surfaces provide control of the aircraft along all three axes. The ailerons, elevators, and the rudder are mechanically actuated. The spoiler panels are hydraulically powered by the blue hydraulic system. The ailerons, elevators, and the rudder incorporate tabs that use aerodynamic forces to reduce the load required to position a control surface. These tabs are also used to trim the aircraft. The tabs are mechanically linked to the associated control surface. The controls associated with the flight controls consist of the two control columns, the two sets of rudder pedals, pitch trim switches on the outboard side of each control wheel, roll and yaw trim switches on the center pedestal, and a trim position indicator located on the flight instruments panel. Spoiler position is also indicated on a spoiler position indicator on the overhead panel. In addition, a standby pitch trim switch on the center console provides an alternate means of trimming the aircraft in the pitch axis. Flaps are controlled by a flap handle located on the right side of the center pedestal. Flap position is indicated on a flap position indicator located on the right side of the center flight instruments panel. A gust lock system provides a means to mechanically lock the ailerons and the elevators when the aircraft is on the ground. In addition, a dampener will limit excess rudder travel speed, particularly during taxi. It also prevents damage from wind gusts when the aircraft is parked. A stick pusher mechanism will mechanically push the control column in the event of an impending stall. Roll control is achieved by a pair of ailerons. There is one aileron on each wing. Each aileron includes a balance tab. This tab moves in the opposite direction of travel of the associated aileron. This provides aerodynamic assistance to move the aileron in the desired direction. The panels on this screen are interactive. You can rotate the control wheels to see how the balance tab operates. Each wing incorporates a spoiler panel that is used to assist in roll control. Spoiler panel deflection occurs when the associated aileron deflects up a certain amount. Therefore, only the spoiler panel in the direction of the turn will deflect. The extension or retraction of a spoiler panel is mechanically controlled, so the loss of DC power will not have any effect on spoiler operation. The ailerons are controlled by the two control wheels in the flight deck. The control wheels also control the spoiler hydraulic valve blocks. The control wheel can rotate 87 degrees to the left or the right. This results in a maximum aileron deflection of 14 degrees up or down. The two control wheels are interconnected by a connecting rod. The movement of one control wheel in the roll axis will be reflected in the opposite control wheel. The ailerons and spoilers are controlled by a cable and drum assembly attached to the right control wheel. The cable is then connected to another drum assembly that drives a series of interconnected rods to control the ailerons and spoilers. The autopilot controls the ailerons and the spoilers through an autopilot roll actuator which uses cables to rotate the second drum. Aileron trim is achieved by repositioning the neutral point of the left aileron spring tab. Aileron trim is electrically controlled by the aileron trim switches located on the center pedestal. Roll trim requires electrical power from the DC emergency bus. Aileron trim is activated by depressing both rocker switches. Both switches must be moved and held in the same direction in order to set aileron trim. The left aileron trim tab can be moved 6.7 degrees up or down. It takes approximately 30 seconds to obtain full roll trim travel. Aileron trim position is indicated on the roll, pitch, yaw, trim position indicator. This indicator is powered by the 26 volts AC bus 1. When an aileron deflects up a certain amount, the associated spoiler valve block will open and a measured amount of hydraulic pressure will be supplied to raise the associated spoiler panel. Normally, this spoiler panel is flush with the upper surface of the wing. It will return to the flush position when the aileron deflection is reduced below the threshold value. Spoiler position is indicated by two spoiler position indicators located on the overhead panel. An illuminated position light indicates that the associated spoiler is not in the retracted position. Pitch control is achieved by positioning the two elevators through the control columns. Each control column mechanically controls the associated elevator. A coupling mechanism also drives the opposite elevator and indirectly positions the opposite control column. The coupling mechanism allows pitch control to be recovered in the event of a jam in the system. By applying a differential force on the control columns, the pitch coupling mechanism is disengaged and the operating control column can then control its associated elevator. Once decoupled, the mechanism can only be recoupled when the aircraft is on the ground. If the pitch system is disconnected, the pitch disconnect light illuminates on the crew alerting panel. In addition, both master warning lights will flash and the continuous repetitive chime will sound. The control columns can travel 11.25 degrees. If the pitch system is disconnected, the pitch disconnect light illuminates on the crew alerting panel. In addition, both master warning lights will flash and the continuous repetitive chime will sound. The control columns can travel 11.25 degrees in the up direction and 6.75 degrees down. This results in a maximum elevator travel of 23 degrees in the nose up direction and 13 degrees in the nose down direction. The elevator automatic tab will travel approximately 50% of the elevator movement. The control wheels on this screen are interactive. You can push or pull the control wheel to see how the tab operates. Pitch trim is achieved by repositioning the neutral point of both elevator tabs. Each trim tab has a dedicated actuator driven by an electric motor. The electric motors are controlled together by the standby trim or individually by normal trim through the MFC. Both actuators are connected by a flexible shaft. The purpose of this shaft is to synchronize the movement of the elevator tabs. If for some reason the tab position differential exceeds a certain amount from each other, both master caution lights will flash, the flight control light illuminates on the crew alerting panel, and the pitch trim asymmetry light illuminates. In addition, this condition will inhibit both the normal and standby pitch control systems. If the autopilot is engaged, this condition will cause the autopilot to disengage. The pitch can be trimmed by means of the trim switches on either control wheel or by the standby trim switch on the center pedestal. Each control wheel has two rocker switches on the outboard side of the control wheel. Both switches must be actuated in the same direction in order to trim the pitch. Trimming is inhibited if the rocker switches are pressed in the opposite direction of each other. It should be noted that the trim switches are spring-loaded to the neutral position. If the normal trim switches are held down in either direction for more than 1 second, the CCAS will sound an oral alert. If the autopilot is engaged, the actuation of the pitch trim switches will disengage the autopilot. The pitch trim system can also be controlled by the standby pitch control switch on the center pedestal. This is a guarded switch. Actuating the switch will drive both electric motors of the trim actuators in the selected direction. As in the case of the normal pitch trim switches, actuation of the standby trim switch will also disengage the autopilot. Full pitch trim travel takes approximately 30 seconds using both normal and standby pitch control. The maximum deflection of the tab while they're being trimmed is 5 degrees up and 1.5 degrees down. Pitch trim position is indicated on the flight control position indicator. The pointer indicates the travel of the right trim actuator. The green band on the indicator represents the normal pitch trim position for takeoff. This band ranges from 2.5 degrees up to 0 degrees. If the trim is outside of this range during a takeoff or during a takeoff configuration test, the master warning lights will flash, the red configuration light and the amber flight control lights illuminate on the crew alerting panel. Stall protection is provided by 2 electrical stick shakers and 1 stick pusher. Each control column has a stick shaker. The stick pusher is connected to the captain's control column only. If the aircraft's angle of attack becomes excessive, the MFC will provide an electrical signal to the 2 stick shaker electrical motors and the control columns will shake. Both alpha probes must agree on the angle of attack before the stall warning or stick pusher is activated. If the alpha probes disagree by a predetermined amount, the stick pusher shaker push button will indicate fault along with a level 2 alert on the crew alerting panel. Similar warnings will occur if power for the stick pusher motor is lost or the flap position signal is incorrect. If the angle of attack continues to increase, the MFC will activate the stick pusher, which will push forward the captain's control column. Since the 2 control columns are interconnected, both control columns will move. If the pitch system was uncoupled, then only the captain's control column will be pushed forward. If the stick pusher is activated, a green stick pusher light illuminates on the right side of the flight instruments panel. Yaw is controlled by a movable rudder surface and a spring tab. The system incorporates a travel limitation unit, or TLU, a releasable centering unit, or RCU, a rudder damper, and a trimming system. Yaw is controlled by the 2 sets of rudder pedals. The rudder pedals mechanically control the spring tab and the rudder is then controlled through a spring. The releasable centering unit, or RCU, centers the rudder when no forces are applied to the rudder pedals. If the aircraft is on the ground and there are no air loads on the rudder, the movement of the rudder pedals will move the rudder until it reaches one of the 2 rudder stops. During this movement, the spring tab is faired with the rudder. Once the rudder has reached one of the stops, the spring tab will travel in the opposite direction that is commanded. If the rudder pedal is actuated while there is an air load on the rudder, such as during flight, the spring tab moves in the opposite direction of the rudder movement. This alleviates the pilot's workload. It should be noted that the amount of spring tab travel increases as the airspeed increases. A travel limitation unit limits the amount of rudder travel based on airspeed. The TLU uses airspeed from the 2 air data computers. The TLU uses an actuator to move a fork which allows additional rudder travel or restricts it. In the automatic mode, the TLU limits rudder travel when the aircraft accelerates through 185 knots. The rudder travel limit is removed when the aircraft slows below 180 knots. Whenever the rudder travel is not limited, the rudder TLU low speed light illuminates green. The TLU can also If there is a fault with the TLU, the fault light illuminates on the flight control panel. This fault could be due to a disagreement between the actual position of the limiting fork and the commanded position, a dual ADC failure, an airspeed data disagreement between the 2 air data computers, or a TLU position synchronization failure. If the fault light illuminates, you would use your quick reference handbook and adjust the rudder travel by moving the switch to high speed or low speed. Switch position will be dictated by aircraft airspeed. A rudder damper regulates rudder travel speed while the aircraft is in flight. On the ground, the damper limits excessive rudder movement due to wind gusts. Rudder trim is achieved by repositioning the neutral point of the spring tab. This repositioning is done by an electrical motor. The motor is controlled by a dual yaw trim actuator lever located on the center pedestal. Rudder trim is commanded by rotating both handles in the same direction. Full rudder trim travel takes approximately 15 seconds. Rudder trim motor position is indicated on the yaw trim position indicator located on the flight instruments panel. The maximum amount of trim is 3 units right or left of the 0 position. When you trim the rudder, the releasable centering unit will disengage until trimming is done. At that point, the RCU will re-engage. The autopilot does not trim the rudder. Therefore, it is permissible to trim the rudder when the autopilot is engaged. Operation of the rudder trim will not disengage the autopilot. Each wing incorporates an inboard and an outboard flap. These flaps augment lift when they are extended. The flaps on each wing are mechanically linked and include a fail-safe design. The flaps are controlled by a flap lever located on the right side of the center instruments panel adjacent to the power levers. The flap lever enables the crew to select one of 3 positions. These positions are flaps up, 15 degrees, and 30 degrees. In order to select a particular setting, the flap lever must be raised and moved to the desired detent. When the lever is over the desired detent, the flap lever is released and it springs into the slot. An amber strip is visible at the bottom of the flap lever when it is out of a detent position. It should be noted that the design of the flap system does not allow the selection of an intermediate position. The flaps are hydraulically actuated by the blue hydraulic system. It is possible to move the flaps with the green system through the hydraulic crossfeed valves. Flap movement is controlled by 4 flap actuators. There is 1 actuator for each flap panel. The position of the flap lever and the actual position of the flaps are used to command the operation of a flap valve, which directs hydraulic pressure to the extend or retract side of each flap actuator. A blue extend flag appears in the flap position indicator when the flap valve is in the flap's extend position. The extend flag disappears when the valve is no longer commanding an extension. If the extend flag remains in view after the flaps are extended, it indicates that there may be a leak in the flap's hydraulic circuit. Flap position is sensed by 2 flap position transmitters. If the MFC senses that there is a difference between the left and right inboard flaps that exceeds 6.7 degrees, the MFC will close the flap valve and the flaps will stop in their present position. In addition, the flap asymmetry light illuminates. Once this happens, the flap lever is inoperative and can only be reset when the aircraft is on the ground. The inboard and outboard flaps are connected by a push-pull rod. If this unit fails, a flap asymmetry between the inboard and outboard flap on one side is minimized by a pin that connects the 2 panels. A flap unlock light on the crew alerting panel will illuminate if the flaps are extended and they retract more than 3 degrees without a flap retraction being selected. In addition, a CRC will sound and both master warning lights will flash. The blue extend flag on the flap indicator should also be in view. When engaged, the gust lock protects the ailerons and the elevators against the effects of gusts while the aircraft is on the ground. It also limits the power lever travel and therefore prevents an excessive power setting while operating in the hotel mode. This system mechanically locks the elevators. The ailerons are locked using an electrical mechanical locking device. The gust lock system is controlled by the striped T-handle located between the power levers. The gust lock system is engaged by pulling the handle towards the aft position. When engaged, the gust lock system will lock the control column in the pitch axis to prevent fore and aft movement of the control column. Locking is accomplished by a series of cables and gears. Each aileron is locked in place by an electromechanical locking device. The locking devices are electrically actuated by switches that are actuated by the gust lock lever. Normally, the ailerons are locked in the neutral position. However, the ailerons may be locked slightly past the neutral point and the control wheel may be up to 5 degrees left or right of center. An aileron lock light illuminates in the event one of the aileron locking actuators disagrees with the position of the gust lock. The alert is triggered by the MFC and consists of a single chime, and both master caution lights will flash in addition to the illumination of the aileron lock light. Engagement of the gust lock can occur regardless of the position of the flight controls. However, the controls must be brought back to neutral in order to positively lock the locking mechanism. Trim position is indicated on a trim position indicator located on the right side of the center part of the flight instruments panel. This indicator shows aileron, elevator, and rudder trim position. The indicator is powered by the 26 volts AC bus 1. The two spoiler unlock lights on the overhead panel illuminate in the event the associated spoiler is not in the retracted position. These spoiler position indicators are powered by DC bus 1. Roll trim is controlled by the two roll trim rocker switches on the center pedestal. Both rocker switches must be actuated in the same direction in order to obtain roll trim. Pitch trim is normally obtained by actuating the two pitch trim rocker switches located on the outboard horn of either control wheel. The switches must be actuated in the same direction in order to obtain pitch trim. Power for the normal pitch trim system is from the DC emergency bus. If you recall, actuating pitch trim while the autopilot is engaged will automatically disengage the autopilot. Standby pitch trim is commanded by the guarded standby pitch trim switch on the center pedestal. Actuation of this switch will also disengage the autopilot. The standby pitch trim system is powered by DC bus 2. The stick pusher push button on the center part of the flight instruments panel controls the operation of the stick pusher system. When the push button is in the off position, the stick pusher and stick shaker systems are deactivated. This will also disable the stall warning audio alert. Power for the stick pusher system is supplied by DC bus 1. The stick pusher actuator is installed on the left control column only. The stick shakers are powered by the associated DC bus. The fault light illuminates in the event of a failure of the stick pusher or stick shaker systems. The travel limit switch on the overhead panel controls the operation of the rudder travel unit. In the auto position, rudder travel will be restricted as a function of airspeed. The fault light illuminates if there is a system disagreement, a dual air data computer failure, inconsistent air data computer data, or a failure of the TLU position synchronization system. If the fault light illuminates, the rudder travel limit can be adjusted by lifting the guard and moving the switch to the high speed or low speed position. The TLU control system is powered by DC bus 1. Rudder trim is obtained by rotating and holding the yaw trim handle in the desired direction. Yaw trim is powered by the DC emergency bus. The flap handle controls the extension and retraction of the flaps. Each flap panel is hydraulically driven by an associated flap actuator. The two flaps on each side are mechanically linked so as to provide a fail-safe operation. In the event the flaps are extended, a clacker will sound if the aircraft speed exceeds the maximum speed for the selected flaps. This concludes the flight controls module.